Hello, you're welcome to this lesson. In this video, you're going to learn how to solve system of linear equations using Jacobi iterative procedure. So let's look at how we are going to do this. Okay, so if you have a system of linear equations, okay, this time around, you're not going to find the values for the variables x1, x2, x3 directly, okay? We're going to use approximations, okay, to get the actual value that will fit into all the three given equations. Okay, so for this, what you normally do is that you'll be given an initial approximation, okay, of the variables, okay. So you use those initial approximations to get your first approximations, okay. And then when you get those first approximations, you use it to find the next approximation. So one thing is that your approximations, okay, will satisfy the equations, okay, but it will not satisfy it completely, as in like it will not be a perfect solution, okay. So you keep iterating till you get values that will fit into all the equations perfectly, okay, and then that will be your solution to the system of what linear equations. So let's look at how we can carry out this iterative procedure. Okay, so first of all, you'll be given initial approximations. Okay, in this case, these are our initial approximations. Okay, so we have the initial approximation for the first variable x1 to be 0, and then we have the initial approximation for the second variable x2 to be 0 also, and then for the third one also is 0. Okay, so what we do is that we are going to consider the first equation, okay, and then we will make x1 the subject, and then we consider the second equation, we make x2 the subject, we consider the third equation, we make x3 the subject. Okay, so when you do that, we are going to have these three equations that we have here. Okay, so you see that we made x1 the subject for the first one, and then we made x2 for the subject for the second one, and we made x3 the subject. Okay, so one thing you have to know is that if you are making x1 the subject, okay, of the equation, then you must not have x1 here, right? And then here too, if you are making x2 the subject, you must not have x2 here, and then you must not have x3 here also. So take note of that. Okay, so now let's look at how you're going to use the initial approximations to get the first approximations. Okay, so let's look at that. Okay, so what you're going to do is that for the first variable x1 that we have here, okay, we are going to use the initial approximations x2, okay, to be what 0, right, and then s3 is also what 0. So those are the initial approximations you are going to use for the first variable x1. Okay, when we do this, okay, we are going to have 0 here, and then we are going to have 0 here also. So then we are going to have x1 to be equal to 3 on 3, which would be what 1. Okay, so that will be the first approximation for x1. Okay, so we are going to have the first approximation for x1 to be, let me write it here, I'm going to have x11 to be equal to 1. Okay, so that'll be the first approximation. So I'm going to do the same for x2 also. So for x2 also, you know that x1 is 0, so I'm going to have 0, and then x3 is also what 0, right? I'm going to have x2, okay, to be equal to 7 on 4, right, which is the same as 1.75, which is the same as 1.75. So the um, first approximation, okay, for the second variable, okay, will be 1.75. So let's do for the third variable also. So for that one too, this will be 0, this will be 0, right? So you're going to get s3 to be equal to 4 on 4, which will be what 1. So you're going to get the first approximation for the third variable to be 1 also, right? So these are the approximations we got after the first iteration. Okay, so what we're going to do is that we are trying to say that our x is 1, our x1 is 1, x2 is what 1.75, and then x3 is what 1. Okay, which means that if you put these values into this system of equation that we have here, we should be able to get the values on the right hand side. So let's do it for the first equation. So for the first equation, you're going to have 3 multiplying 1, okay, plus x2, which is what, 1.75, okay, minus x3, which is what, 1. So let's see if you are going to get 3. So you have 3 multiplying 1 plus 1.75 minus 1. So this gives me a value of 3.75, right? So you see that although we are getting a value closer to 3, but it's not too close to 3, okay, which means that our approximation is not really correct, okay, because you are supposed to get 3 or a value very, very close to 3, but we are getting 3.75, which is somehow far from 3, okay. So that means that our first approximation doesn't really satisfy the equations, okay. If you do same for the other two, you're going to get values that are not actually close to 7 and 4. So for that reason, you will have to continue the iteration procedure to start getting values that we put into the equations will give us values that are closer to the right hand side values. So you continue with the iteration. So now these values become our approximations now, okay. So we're going to take these values and then substitute them into the equations again, and then see the approximation values that we are going to get and see if that also give us a value closer to the right hand side values. Okay, so now let's continue. Okay, so we are going to iterate again, okay. So now we have x1, okay, to be 1, x2 to be 1.75, and then x3 to be what, 1. So now let's come back to this equation, okay. So we are going to have x1 to be equal to 1 over 3, okay, multiplying 3 minus x2. Our new x2 is 1.75, right? And then our x3 is now 1. So let's see what you are going to get. You're going to have 1 over 3 multiplying 3 minus 1.75, okay, plus 1. This will give us a value of 0.75, okay. So that would be the second approximation for x1, okay. So we are going to have this to be 0.75. So let's do the same for x2. So for x2 you are going to have 1 over 4, okay, multiplying 7 minus 2x1. The x1 are going to use this one, which is 1, okay, minus x3, which is what, 1. So let's see what you are going to get. So we have 1 over 4 multiplying 7 minus 2 multiplying 1 minus 1. This will give us a value of 1. So that means that the second approximation for x2, okay, will be 1, right? Okay, so now let's find the second approximation for x3, which will be 1 over 4, okay, multiplying 4 minus x1, which is 1, okay, plus x2, which is 1.75. So let's see what you are going to get. You have 1 over 4 multiplying 4 minus 1 plus 1.75. Okay, let's see what you're going to get. You're going to get a value of 1.1875. Okay, so that will be the second approximation for the third variable x3, okay. That will be 1.188. Okay, so we have the same here, okay. So what you do is that you continue iterating to get values that will actually satisfy the three equations, okay. So let's look at the approximations we have here, okay. Let's use this and then substitute them to the equations. So in this case I'm going to use the last equation, okay. So I'm going to have x1, which is 0.75, okay, minus x2, which is 1, plus 4 multiplying x3, right, which was what, 1.1875. Over here I rounded it, okay. I rounded, that's why we have 1.188. So let me use the 1.1875. So I'm going to have 1.1875, okay. So let's see what you're going to get. Let's see if you get the 4. So you have 0.75 minus 1 minus 1 plus 4 multiplying 1.1875. Okay, so this gave me a value of 4.5, which is a little far from this 4. Okay, that means that we are still not close to the value that will actually satisfy the equations perfectly. So we will continue iterating to get a value that will actually satisfy the equations. So you can be given a limit, okay, that okay, iterate up to a point where you have x1 to be this, x2 to be this, and then x3 to be this. Okay, you can be given a limit. So with this question, it says that we should apply Jacobi method till the last two consecutive iterations have a difference less than 0.005. So you say you should iterate till the last two consecutive iterations have difference less than what 0.005. So you are going to continue iterating. Okay, we use the same procedure that we used to iterate, okay, till we get the value that the difference between the last consecutive iterations is less than what 0.0005. So if you look at what I have here, the iteration process was continued. Okay, this is the first one, we did this, and then this is the second iteration, this is the third, the fourth, the fifth, all the way to the 10th iteration. So you iterate till the difference between the last two consecutive iterations is less than what? There should be less than what? 0.005. Okay, so let's look at what we have here. Let's check and see if it is actually true. Okay, let's look at these last two iterations. So what I'll do is that I will subtract 1.0003 from 0.9999, okay, and see if it is less than 0.005. So I'll do it for uh, all the three variables. Okay, so for the first one, you're going to have 0.9999, okay, minus 1.0003. So you're going to see if this will be less than 0.0005. So let's see. So we have 0.9999 minus 1.0003. This gave me a value of minus 0.0004, and of course this is less than 0.0005. Okay, so let's do it for the second one. You can't confirm with just one. Okay, you have to check for all the three values. So the next one, I'm going to have 0.9998, okay, minus 1.0004. Okay, let's see if this will also be less than 0.0005. So you have 0.9998 minus 1.0004. Okay, this will also give us a value of minus 0.0006, which is also less than 0.0005. Let's do it for the last value also. You have 1, okay, 0.0000 minus 1.0002. Let's see. So that'll be like 1 minus 0, 1 minus 1.0002, which will give us a value of minus 0.0002, and this is also less than what? 0.005. So this is the point where we are supposed to end. Okay, this is where you are supposed to end. So if you actually pick these values, okay, and then substitute it into the equations, you see that you'll be getting values that are closer to the right hand side values, right? So we have 0.9999 and then 0.9998. Okay, so let's try that. Okay, so we have x1, okay, to be 0.9999, okay, and then x2 to be 0.9998, and then s3 to be equal to 1.0000. So let's do the substitution. So let's substitute this into equation 1, okay, and see what you are going to get. Let me write down the equation 1 again. So for the equation 1, we have 3x1, okay, plus x2 minus x3, and then this should be equal to what? 3, right? So let's do the substitution and see if you are going to get 3. So you're going to have 3 multiplying 0.9999, okay, plus 0.9998, minus 1.0000. So let's see if you're going to get a value closer to 3. So you have 3 multiplying 0.9999, okay, plus 0.9998 minus 1. So this gives us a value of 2.999995. So you see this is actually close to 3. Okay, so you see that at the end we are getting approximation values which actually satisfy the equations, not perfectly, but gives us a value which is far closer than the previous iterations. Okay, so this is what Jacobi iterative method is about. Okay, so this one you don't get your answer straightforward. Okay, you use approximations to get your answers that satisfies the equations. Okay, so from here you can actually see that you can see that x1, okay, should be equal to 1, right? And then s2 should also be equal to 1, and then s3 should also be equal to what, 1, because if you look at the values that we are actually approaching 1 for each one of them. Okay, so let's try and then substitute 1 in place of other variables. So with equation 1, let me free out some space. Okay, so with equation 1, you are going to put 1 there, okay, and then see what you are going to get. Okay, so even from now I can see that if you put 1 there, you're going to get 3. So you're going to have 3 multiplying 1 plus 1 minus 1, and this will give us 3. And then for the second one also, you're going to have 2 multiplying 1 plus 4 multiplying 1 plus 1, right? So you're going to have 2 plus 4 plus 1, and this will give us 7. And then for the third one, I'm going to have 1 minus 1, okay, plus 4 multiplying what? Okay, it's actually 1 minus 1, okay, plus 4 multiplying 1, and this will give us what? 4. So you see that our x1, x2, and x3 are actually 1, but we didn't just solve them directly. Okay, we used approximations. Okay, so the difference between the last two consecutive iterations were less than 0.0005. Okay, so to prove this also again, okay, you can try and then subtract the 8 iteration values, okay, from the 9 values, and see if you get values that are less than 0.005. So let's do that. So the first one, you're going to have 1.0003, okay, minus 0.9989, right? So let's see if this will be less than 0.0005. So we have 1.0003 minus 0.9989. So this gives me a value of 0.0014. Okay, so even this first value here is greater than 0.0005, right? So that tells you that that's not the point that you're supposed to end. Okay, so if you do it for the second one also, you're going to have 1.0004 minus 0.9998, right? So let's see what you're going to get. 1.0004 minus 0.9998. This will also give me a value of 0.0006, which is also greater than 0.0005, right? So this will give you a clue that that's not where you're supposed to end. So you continue iterating till the difference between the last two consecutive iterations is less than what? 0.005.